So in this lesson today, we are going to be discussing some multi-zone relay centers. In today's modern society, modern world, in HVAC, you're going to see more and more homes be zoned. Now, as I'm going through this presentation, I am going to assume that everybody knows what zoning actually means in a home. I will be covering zoning in a different lesson, but for this point, we're going to be talking about the multi-zone relay center and control. So, here we have a Taco brand multi-zone relay center. You know, looking at the picture, they can look a little intimidating. But mostly what they are doing is they are telling your boiler and heating source which part of the house needs to be heated. The reasons why we have gone to zoning is for many reasons, honestly, but the big one is obviously energy efficiency. We don't need to necessarily be heating an entire home altogether if we're not going to be occupying every single part of the house. So by having a zone system, you are able to control each individual space of a home. Your bedroom can be a zone off of the boiler. Living room could be another zone. Kitchen, dining room, bathroom, so on and so forth. They can all be each individual zone, and they can have their own temperature. So by doing that, we would actually install what is called a multi-zone relay center. Okay, so the multi-relay center or zone panel, as we usually call them, is designed to centralize the wiring and control operation of several independent circulators or zone valves. With each individual zone valve or circulator, those are what's going to be controlling whether or not a part of the house gets heat or not. Okay, so multi-zone panels, we can get them in a variety of different zones, okay? 2, 3, 4, 6 zones, to be, exact, is the type of panels that we can have. So what does that mean to us? Well, if we have a 2-zone multi-zone panel, that means that we're going to have 2 thermostats, 2 circulators, or 2 zone valves. Where would you find a, say, 2-zone zone panel? You could probably see that in a home, maybe like a raised ranch, maybe, where, maybe one zone is downstairs and another zone is upstairs. A 3-zone, 4-zone, 6-zone type zone panels, you're probably going to see those on a lot of your bigger homes where we are now separating each individual room or space into their own heating circuit. Like I said before, like your master bedroom could be a zone, the spare room could be another zone, living room, kitchen, dining room, all could be their own separate zone or their own separate heating circuit, so to speak. Okay, we can also get your multi-zone relay centers with or without priority. Now, what do we mean by priority? Well, it's basically, as the word says, priority. Which one is the most important? So we have a couple different ways and a couple different things that we can do. Okay, so here we have a wiring diagram for a multi-zone relay panel. Okay, let's just take a look at just some of the basic characteristics of this diagram. Okay, well, down here, N and H, that's going to be supplying our zone panel with 120 volt power. Okay, this jumper right here that's off of H, that's going to send power into my 120 volt VAC input. So that's going to send power up through here, which is now going to send it out through my contacts, which are internally wired into the circuit board of the zone panel. So I can wire a zone out that's going to require 120 volts. For example, maybe like another circulator or something like that could come out of this terminal here. But in this case, as we can see here, I have my circulator coming out of H. So power, 120 volts, will be coming through here, through my jumper, up. Once this normally open contact closes, it will now send power down to my circulator, which will turn on the circulator, and then back to my neutral. Okay. Up here would be all of my 24 volt stuff. This is where all my thermostats would be connected. In this case, this is probably a single zone, two zone zone panel. So obviously my 24 volt, here's my thermostat, which is just going to make my connection. So once my thermostat closes, it will energize all of my 120 volt circuitry down here, which in this case is nothing more than my circulator. And my TT, or my aquastat, will just be connected right here, which will just tell the boiler and the zone panel that we have a call for heat. Okay, just another version or another picture of all the different sizes that we have for your typical zone panels. Okay, so here's your 2 zone. Here's a 2 zone. Here's a 3 zone. Here's a 4 zone. Okay, so on and so forth. In many cases, 2 or more multi-zone relay centers can also be connected together if needed to handle additional zones. Like we say, we could probably go up to about 6 zones on one panel. But let's say we had to have 8 zones of heating. I can take a 6-zone panel and a 2-zone panel and mount them onto that boiler and wire it accordingly so to make up my 8 zones of heating. A multi-zone relay center has terminals for each zone thermostat along the top of its printed circuit board and terminals for each zone circulator along the bottom. So when I think about zone panels, I like to kind of take a line, go right down the center of them. Everything on the top is all my 24 volts. Everything on the bottom is all my 120 volt stuff. You will find on many of your zone panels that you're going to have a transformer on there. It's going to be mounted onto the panel itself. That transformer is what's supplying the 24 volts out to your thermostats. Your thermostats communicate with the circuit board through all the resistors and relays and stuff and other stuff that's on the panel itself to turn on your zone panel, your zone valves, circulator, so on and so forth. Okay, when we are done with a lot of our multi-zone panels, we always want to try to make sure that the installation and the wiring is always neat and organized. If you can label your wires, if you can label your circulators to which zone goes to what, you are making a service technician's job so much easier when it comes to troubleshooting and repair of that particular type of application. Because the bigger your zone panels are and the more zones you have, the more wires you're going to have. Remember, if you have an 8-zone panel, you have 8 thermostats. If you have 8 thermostats, you're going to have 8 circulators or 8 zone valves that's going to be fed out of this panel. that can kind of get a little messy. So we're going to want to try to make sure that our wiring and everything is nice and neat. Okay, so here's an example right here of what we were just talking about. This here, we have actually what's called the priority zoning circulating control with its switching relays. So if you look right down here, we have 1, 2, 3, 4, 5, 6, 7, 8 zones. 8 zones of heating. 8 thermostats, 8 circulators. There's 4. There's another 4. Okay, so this, if you'll see, we have what's called a master priority zone panel, and then we have slave zone panels. The master circular zone panel is what really controls the entire operation. This guy here is telling what these other panels are supposed to do. This guy is going to tell whether or not the boiler needs to come on. As you can see right here through this wire right here, this wire is coming down. It's wiring into my boiler. This is also going to be sending out for my my powering up my zone panels, my slave panels. Okay, so this guy here is what's going to determine whether or not heating or even air conditioning in some cases is actually going to come on. Some older style zone circulating systems, they used to actually have a little switch on there, a heat-cool switch on them. And what would have to happen in the cool heating season, you would have to flip the switch to the heating mode, which will now trigger the circuitry throughout the circuit board for, to communicate with your boilers or furnaces or whatever it may be. Or if it was in the dead of summer, you would switch that to the cooling mode, and it would circulate and it would communicate with your outdoor condensers, air handlers, so on and so forth. That's probably have gone away. I'm not 100% positive on it, but I believe most of our zone panels that you see today are automatic changeover. You don't necessarily have to go in there and switch any sort of dip switches or anything like that to go between heating or cooling. Okay, the 24-volt power for the thermostat circuits is generated by the transformer inside the relay center. And then when a particular zone thermostat calls for heat, an associated zone relay in the center is now turned on, which will now send that signal to turn on again, a circulator or a zone valve, depending on how it's wired. Okay, in the systems using zone circulators, that relay provides a line voltage output to drive the associated circulator. And when the system is using zone valves, a 24-volt output is turned on to operate the associated zone valve actuator. Okay, again, circulators in hydronic heating, they're going to operate off of 120 volts. Your zone valves, they're going to be operating off of 24 volts. So when you are looking at a hydronic system, that should give you a very good indication of when you're using an electric meter to troubleshoot what voltage readings you should be getting across your zone valve or across a circulator. Hey, here's another typical diagram. Again, this is actually a cold start single zone, one zone switching relay. Again, look. Here's my thermostat, 24 volts, R and W. Okay, those R and Ws will now communicate with your circulator through this normally open contact. Okay, so once that thermostat calls for heat, that contact will now close, which will now turn on your circulator, and now you'll actually have heat. The other additional terminals that you see here, those are all going to be for limits and safeties and stuff like that. If you are wiring, maybe domestic hot water, an indirect water heater, type of stuff like that onto this panel so that you can control basically all aspects of the heating circuit. Okay, this one here is a 3-zone system. Again, this case is here we got 3 thermostats. Okay, this is most of the time it's going to be labeled zone 1, zone 2, zone 3, zone 4, zone 5 in this case. In this case, we're taking a 5-zone panel and we're only going to use 3 of those. This guy is now zone 1, is going to be communicating with this zone valve down here. Again, zone 1. Okay, notice how they're labeled. Zone 1, zone 1, zone 2, zone 2, zone 3, zone 3, so on and so forth. So what's going to happen is if zone 1 thermostat calls for heat, it's now going to be communicating with zone 1 down here, which is in this case a 3-wire zone valve. So this guy will actually open based off of what this thermostat's doing. Okay, same thing with this guy. This one here, thermostat closes. This one here is a Taco 3-wire zone valve. Okay, usually when it comes to wiring them, it's pretty easy. Terminal 1 goes to terminal 1, terminal 2 goes to terminal 2, terminal 3 goes to terminal 3. This one here, this is zone number 3, and okay, and this one here is a Honeywell zone valve or a 4-wire zone valve. Usually when we are wiring those, our motor, which is going to be our 2 yellow wires that are coming off of that zone motor, is going to be wired to terminals 1 and terminal 2. The red wires, which is our end switch, which is nothing more than a proving switch to prove whether or not that zone valve actually opened or not, they will be wired to terminals 3 and terminal 4. And what's nice about a lot of your zone panels is you have nice little indicator lights on the side of them. These indicator lights will tell you which thermostat is calling for heat, which zone valve is open, and which one is closed. If the thermostat is calling for heat, the little light will turn on. If the zone valve actually opened, the little light will come on all the way down the line. Okay, it also tells you whether or not the zone valve panel actually gets power. This light will be on all the time for your power. Okay, a separate relay in the controller also is energized whenever 1 or more zone relays are operated. And the contacts in this relay do not operate an output voltage. Instead, they are an isolated set of contacts, just like a switch. So based off of what is happening, if whether or not the thermostat's calling for heat or not, that contact will open or close. Okay, these contacts can be used to signal other equipment in the system that a call for heat demand is present. And in many systems, this contact is used to turn on the heat source, among other options. Okay, what's nice about zoning is that you have a lot of different options to use at your disposal to do different things and to control different components in that heating or cooling circuit, whatever it is that you're working on. You have the ability to also have zone panels get wired into alarm systems, especially for like commercial and industrial type applications where you can, maybe if you have some sort of processing or emergency heat applications, then you can use, those terminals to trigger an alarm system, smoke system, whatever it may be. This one here is kind of the same thing. This one's a master and a slave thermostat. Just to kind of give you another option on how things are wired. Okay. This one here, you got one thermostat, and this one thermostat could probably be used for a big commercial room, maybe like an office area where you might have to have circulators getting powered for different baseboards, something like that. So you got a lot of different options that you can actually do with your zone panels. Okay, multi-zone relay panels can be set up to have a priority zone. And when the panel is set up this way, the control shuts off all other zones except for the one designated as the priority. Okay, when we are having a zone panel, typically your priority is going to be your indirect water heaters. Okay, especially for residential applications. This allows the full output of the boiler to be available to that priority zone. The most common priority load is, again, your domestic hot water. Since the full output of the boiler is directed to your domestic water heating, hot water is produced very quickly. The indirectly fired storage water heater, when set up with priority, can produce several times the hot water in a given time period than like an electric water heater. And then this increases system efficiency and saves the customer a lot of money. Okay, so right here's a nice, great example of what we would probably see for a boiler with indirect fired water heater. So on this panel over here, if we were to pop it off, this indirect water heater would actually be wired for priority. Okay, and that's what it would look like when everything is actually all wired. Okay, so here's my circulator. Okay, and here's all of my thermostat wires. Okay, again, wired into my boiler to communicate with my little water cutoff, aquastat, so on and so forth, so that everything is in working order.